Welcome to Lawrence Livermore National Laboratory's webinar on the Portunus Project. My name is Hank Glauser. I'm the Principal Investigator, Global Security. The Portunus Project is designed to reinvent containerized commerce in the United States. We do this by cutting freight offload times by 60%, improving intermodal interconnectivity, allow the largest ships to access all U.S. ports, reduce the need for U.S. ports to make constant large infrastructure improvement investments, and improve the resiliency of the supply chain, simultaneously improving logistics, the economy, environment, and security in a way that makes sense for business. Before we can tell you how this is done, I need to bring everybody up to the same page. What you see before you is a graphic of how goods are moved in the United States. There are three pathways: railways indicated in tan, roadways indicated in red, and waterways indicated in blue. Given that U.S. Department of Transportation reports 576 tons can be moved per mile for a gallon of gas on a barge, with a corresponding 155 tons moved a mile with a gallon of gas using a truck. Waterways are clearly the most efficient way to move goods in the United States. This process of using barge and lighter craft is called short sea shipping. But how are goods moved in the United States? Instead of accessing the commercial waterway system, which is a correlation where the population is in the United States, 70% of the U.S. population lives on the east of the Mississippi River. Goods are moved largely from Asia to the West Coast, and then from West Coast to ports or to points east. Okay. This is done because of the Panama Canal. Panama Canal is a choke point with a capacity of 4,000 TEU ships. So a TEU is a 20-foot equivalent unit. What you see on a roadway is a containerized truck, a 40-foot unit, which is 2 TEU. Ships carrying 4,000 TEU can transit the Panama Canal. Unfortunately, the shipping industry has outpaced that, producing 18,000 TEU ships coming online this year, or last year. Okay. The Panama Canal Authority, in seeing the trends of the future, and when they first started the design, envisioned a Panama Canal ship no greater than 12,500 TEU, so they built the locks to accommodate the new larger ships in their imagination, 12,500. Clearly, the shipping industry has outpaced this, indicated by the graph farthest to the right. The shipping industry has transitioned, moving to the larger ships. And the reason they're doing that is because those larger ships are more profitable. They provided an economy of scale for goods movement. Okay. How are the ports reacting to all this? The ports are spending about $47 billion in infrastructure improvements. And depending on where the ports are located, whether east or Gulf Coast, they're trying to get the 12,500 TEU ships in, or maybe even luring in the larger ships from Europe. Okay? And the West Coast ports are trying to maintain their market share, expanding to the even larger ships. The larger ships have a draft of 50 feet, or about 50 feet. Average U.S. harbor depth is 35 feet. So these port improvement projects include a large amount of dredging. They also include extending the quayside length to handle the larger ships and retooling the cranes. All the cranes on a particular pier or quayside need to be able to extend above and across these larger ships. And so that's huge infrastructure investments. In addition to those investments in essentially along the pier side, there are investments in intermodal connectivity. These ships disgorge large amounts of freight, getting them off the ports, which are cramped in their real estate, inland so they can be sorted is a vital thing, and that's called intermodal connectivity. But ports aren't the only issues involved in the infrastructure. The intermodal connectivity isn't the only thing involved in infrastructure improvements for the ports. Terrorism. Terrorism is also a factor. Today, because those ports are critical to the U.S. economy, they are part of our infrastructure. They're located in large population centers, and they're also on our borders. They represent an attractive target to terrorists. Terrorists, though they don't have WMD devices now, or may not have WMD devices now, the certainty for that in the future is decreases. 10 years from now, 20 years from now, who could say what the capabilities of those terrorists are? So the question is, if a terrorist event or someone demonstrates a WMD anywhere in the world, what happens to the maritime commerce system? Enter the Portunus project. Portunus is a series of offshore ports located in major shipping lanes. They can offload an 18,000 TEU ship in 36 hours. Currently, Los Angeles and Long Beach can offload a 15,000 TEU ship in 4 to 7 days. So this is a huge improvement in freight handling and movement. Okay. How it works is a hub and spoke distribution system reaching the population centers of the U.S. You have essentially 5 Portunus ports. They're receiving freight internationally from overseas. And then that freight is inspected and transferred to smaller ships, which can then move through the commercial waterway system very efficiently as a hub and spoke distribution system. Exports work the same way. Those smaller ships carry their freight to the platforms, and then that freight is reloaded onto the larger ships. Those larger ships take back off. Okay. How this is going to happen. The Lawrence Livermore National Laboratory will evaluate current technologies and develop the technologies needed for the Portunus project. This includes engineering design and computer modeling, logistics software development, prototype development and deployment, automated systems, dynamic stabilization for these platforms, renewable offshore energy, desalination technologies, ocean mooring, and breakwater systems. Clearly, each of those technologies have spin-offs all along the way. Let's take a quick look at a little more detail on the technologies involved. New structures and platforms and systems. Pictured here is a concept by Float developed by DARPA in the 1990s. Automated freight handling systems, currently in use in Europe. Multi-pick cranes, currently in use in Asia. Screening technologies. Databasing and big data, being able to identify a container, its contents, and the location in the yard, and then staging that for load and offload. And then ocean-based renewable energy, wind and wave, and new materials, which clearly you have in the picture because they haven't been invented yet. So people ask, how many of these technologies are purely in R&D right now, and how many are existing and maturing, and I've given you a graphic to represent that. The benefits of the Portunus project, clearly faster loading and offloading times resulting in greater profits. It protects the critical infrastructure, coastal population centers, and provides resiliency for maritime commerce. The U.S. economy is strengthened by not pushing dollars overseas to inspect freight. Also, the economy is strengthened for more efficient goods delivery and domestic industry revitalization, spurring job growth. Estimated $2 billion in tax revenue based on accurate inspection and of imported goods. This is for the first year only, as shippers realize that the freight can be inspected quickly and accurately. And lastly, it provides an economy of scale for existing ports to keep up with their technologies. How you can play a role. You can partner with LLNL to advocate either with your representatives or joining us in congressional committees in search for additional funding. You can be a research partner, allowing us to instrument your current or existing offshore projects. We need the data to be able to put into the models so we can do the engineering and computer modeling and design. Work with other LLNL partners to develop these concepts. Partner with us to develop the intellectual property which will be used in the technology and tech spin-offs. Lastly, participate in engineering design. You can provide your expertise to solve the problems we face. Lastly, I want to thank you for your time and offer you to contact Hannah Farquhar at farquhar3@llnl.gov for additional information on the project. It's been a pleasure.